The last video we talked about a shortcut for finding critical points for profit. Let's find a shortcut for finding critical points for average cost. Another phrase that is said in the business and economics world is that average cost is minimized when average cost equals the marginal cost. And again, it's mostly true. That does give us a critical point. Remember that average cost is your total cost divided by your quantity. You can call quantity Q or X. So this is minimized when the derivative equals 0. To take the derivative here, we need the quotient rule. Quotient rule says low, d high, minus high, d low. The derivative of Q is just 1. Q is our variable, right? Just Q is X here. The derivative of X is just 1. Low d high minus high d low. Square the bottom and away we go. So the critical point is when this derivative equals 0. Which is when this happens. Remember in an earlier video I said if anytime we have an equation with fractions, to solve it, we can just get rid of the fractions. Multiply both sides of this equation by the least common denominator. That'll give us 0 is Q times C prime minus C. Now, we simplified it, which is great. But this is still not. What are we supposed to do? The question is, how do we minimize average cost? And specifically, how does that have to do with this sentence? Average cost is minimized when average cost equals marginal cost. Oh, well, C prime, right? That's marginal cost. So if we add C to both sides, look what we get. That there's a critical point when the total cost is Q times the marginal cost. But if we divide both sides by Q, we get that we have a critical point when this is true. And what is total cost divided by quantity produced? That's average cost. So we just showed that a critical point of average cost occurs when average cost equals marginal cost. Because we know what average cost is. We know there's a critical point when its derivative equals 0. This is its derivative. We found when the derivative equaled 0. It was when the average cost equals the marginal cost. So this is another shortcut that you can use if you ever need to minimize average cost. Or, again, you can just do it normally by taking the derivative and setting it equal to 0. Just like in the last one, we did this one normally, but we could have also used this blue shortcut up here. So, want to use the shortcut? Go for it. Want to do it normally so you have fewer things to remember? Go for it. I usually don't use that shortcut, but we'll use it for this one. The cost in dollars to produce Q gift baskets is given by this function. Find the quantity where the average cost is minimized. Well, we know average cost is minimized when the marginal cost equals the average cost. So if you just wanted to use the shortcut, that's all you need to do. What's the marginal cost? Marginal cost is the derivative of C, which is just 2. Right? What's the derivative of this? It's just a power rule. 2 plus 0.2Q. What's the average cost? Average cost is total cost divided by quantity produced. That's average cost. We're using the fact that average cost is minimized when this is the case. To say that, okay, let's use this marginal cost and average cost. Set them equal. Here's our marginal cost. Let's set it equal to our average cost. The solution to this is where the average cost is minimized, according to our calculations from the last point. This is our marginal cost. This is our average cost. We're setting them equal. Let's solve it. Any equation that has fractions, multiply both sides of this equation by the least common denominator. Now on the left-hand side, we have to distribute to get 2q plus 0.2q squared. And the right-hand side is really nice. We get cancellation. That's the whole point of multiplying both sides of an equation by a least common denominator. It completely gets rid of the fraction. Now we need to get all the terms on the same side. Up to you how you do this. I like my q squared term being positive. So I'm actually going to subtract over everything to the left. Ooh, look at that. The two q's are going to cancel. Did not expect that. So now the right-hand side is just 0. The left-hand side is negative 160. These cancel. Plus 0.1 q squared. Really nice. Add that 160 right back over. Because if you're solving a quadratic equation with q's in it, you need everything on the same side. But if there are no q's in it, you can solve it much more directly. That's why I moved the 160 over, and then I had to move it back because we lost that q term, which changes how we want to solve the equation. Now we divide both sides by 0.1 and get q squared equals 1600. Take the square root. We'll get a plus or a minus. And I think it's 40. But I'm going to check my answer. Anytime you take the square root of both sides, you get a plus or minus. It is indeed 40. But again, we're trying to determine how many things to sell, how many gift baskets we want to sell to minimize our average cost. So we're not going to sell negative gift baskets. We're going to sell 40 gift baskets. This gives an average cost of what? Well, this is our average cost. If we're selling 40, let's find out what our average cost looks like. Let's do it this way. 160 plus 2 times 40 gift baskets plus 0.1 times 40 squared gift baskets, all divided by 40 gift baskets. Our average cost is going to be about $10 per basket. Does this make sense? Doesn't sound like we're selling very much. Maybe we're a small business. Maybe we sell a lot of other things. Yeah, selling 40 gift baskets will give us an average cost of $10 per basket. Okay. Our fixed costs are 160. So it does make sense that we're going to want to sell at least quite a few to get through that. Each gift basket will always cost $2 in materials. And then the more and more we produce, the more we're going to be straining our production capacity. So that's what that term means. Yeah, looks believable. $10 per basket. Should be a number bigger than 2, because that's the cost that we always have to produce for a gift bag, and we have to incorporate our fixed costs and these like production straining costs as well. Our costs are made up of 3 things here. Looks believable. That's basically the section. So lots of problems. Some of them take a long time. Let me know if you have questions. Hopefully I gave you some examples. The next video, I'm going to do some of the trickier looking homework from the book.